Problem 4. Haley wrote the first letter of her name on a piece of paper. Here's her letter. How many lines of symmetry does the shape of this letter have? If I take a look at this shape in this letter, and I want to make lines of symmetry. It means if I fold it or I cut it on that line, I'll have two congruent parts. Same size and the same shape. Looking at this letter, I can definitely see that there's at least one line of symmetry. There's one line of symmetry vertically. If I use that line and I folded that letter or I cut that letter, I would end up with two equal parts. But that is not the only line of symmetry this letter has. This letter also has a line of symmetry horizontally. Because again, if I took that line and I cut the letter or I folded the letter, I would have two equal parts. Now for this letter, I can't make any diagonal lines of symmetry. If I tried to make any lines of symmetry diagonally, they wouldn't line up. They wouldn't match up. I would have one side down here on the bottom that's got this hole cut out, but it wouldn't match up on the other side. Same thing if I went this way. The holes wouldn't match up. So I can't use any diagonal lines of symmetry. So this shape only has two lines of symmetry. Got a vertical line of symmetry. It's got a horizontal line of symmetry. Again, if you're not sure, use your fingers. Trace the letters, trace the lines. You'll see that like here, my fingers are doing the exact same thing. I trace them. Same thing if I go with the horizontal line. I'm tracing the lines here. My fingers are doing the exact same thing. I've got two lines of symmetry on that letter. Problem 5, telling me to look at this figure, and it asks which line segments appear to be perpendicular. Jaylene told us earlier that perpendicular lines are lines that have to cross. But what has to happen if they're perpendicular? They're going to cross and something else is going to happen. Kylie?
They have to be a right angle.
It has to be a right angle. So that's what I'm going to look for. I'm going to look for right angle. A says I should look at line MN and line PO. MN, PO. Well, I mean, look at those lines. Even if I try stretching them out, those lines don't cross. I've got no angle check because they never run into each other. What do we call those lines? Lines that never ever touch. They never run into each other. They're not called perpendicular lines. They're called what? They never run into each other. Never ever cross. They'll go on forever and ever and ever, and they'll never cross. Call them what? What are those called? Lines that never ever cross. We've been talking about them today. They start with the P. What do we call those lines? Lines that never ever cross. Start with a P. Christopher, what do we call them?
Is it a polygon?
Not polygon. Polygon is a shape. Has to have more than two sides and it's no opening. But two lines that never ever cross. Bradley, you remember?
Parallels.
Parallel. These two lines are parallel, but not perpendicular. B says, well, what if you check line MN and line OM? Okay. MN and ON. Oh, okay. So this angle here. Try it. I can't see all my angle. Too small for my sticky note to fit. What kind of angle was it if the sticky note is too big to fit? Kaylee?
Acute.
An acute angle. But we said perpendicular lines make right angles. So that's not it. C says to check line MN, okay, and NO. Okay, so MN, NO. All right. My sticky note fits perfectly. What kind of angle is it if my sticky note fits perfectly? What kind of angle is it, Noah?
Right.
The right angle. That's the kind of angle we were looking for. D says check line MN and MO. Okay. But we already did that. Last time they called it OM, this time they called it MO, but it's the same line. And we checked it earlier. It was an acute angle. I'm pretty sure the lines on my paper didn't move. So I'm pretty sure it's still an acute angle. Which means it's still wrong. So the only one that was perpendicular was C. Lines MN and NO.